Exercise 12.2, Problem 8, Discussion. So let's read the problem. A basket contains 20 apples and 10 oranges, out of which 5 apples and 3 oranges are rotten. If a person takes out one fruit at random, find the probability that the fruit is either an apple or a good fruit. So again, the key word is or. So or is means you have to use the addition theorem, addition of probability theorem. Okay. Right. Now, what they are asking is the apple contains 20 apples, 10 oranges, out of which 5 are bad apples, rotten apples. So, which means good apples is 20 minus 5, 15. 3 oranges are rotten. So, 10 minus 3, that is 10 oranges minus 3, 7 good oranges are there. Now, let A be the event of selecting an apple. Okay. And what is n of A? N of A is number of apples is 20. Right. Next is B. Let B be the selecting of a good fruit. Good fruit means it can be a good apple or it can be a good orange, right? We just now saw the number of good apples is 20 minus 5, 15, and this is 10 minus 3, 7. So 15 plus 7, 22 good fruits are there. So N of B is good fruit, that is 22 good fruits are there. So that is the key principle which you need to use, and based on that we'll work it out. Okay. So number of apples is 20, number of oranges is 10, number of rotten apples is 5, and number of rotten oranges is 3. Okay. What are we asked? We are asked to find probability of a fruit. Probability fruit drawn is either an apple or a good fruit. Okay. Or is keyword. So you have to use the probability of A union B formula. Apple is A, good fruit is event B. The formula is the additive theorem. Probability of A union B equals probability of A plus probability of B minus probability of A intersection B. And another formula which I have missed to mention in all the formulas, in all the problems, is probability of A is N of A divided by N of S. Okay. So let's get going. Step 1. First find N of S. We don't need to find the sample space. We just need to find N of S, because these are all counting variables, right? But in the dice and everything, we need to know the outcome itself. Here and then only you'll be able to count it. But here it's all counting variables. So we don't need to find sample space. We just need to find the N of S. So N of S is 20 plus 10. 30 is the N of S. That's the total sample space, total number of fruits. Let A be the event of getting an apple and B be the event of getting a good fruit. Find N of A. N of A is number of apples, that is 20. Now N of B is what? B is a good fruit, right? So how many good fruits are there? The good fruit can be good apple and it can be good oranges. So we need to find the number of good apples and add that with the number of good oranges. How will you find good apples? We know the rotten apples is 5 and you know the total number of apples is 20. So 20 minus 5 is 15 good apples are there. Similarly, number of oranges is 10 and number of rotten oranges is 3. So 10 minus 3 is there is 7 good oranges are there. So N of B will be 15 plus 7. 22 good oranges are there. Okay. Next, calculate probability of A, which is nothing but N of A divided by N of S. That is 20 divided by 30. Am I right? Similarly, find probability of B and probability of A union B. We need to find N of A union intersection B. I'm sorry. That I'll do it in the problem. Okay. That is number of good apples. A intersection B means it must be an apple and it must be a good fruit. So which means it is good apple. How many good apples are there? So probability of getting good apple. Right? That is what they mean by saying probability of A intersection B. Then, once that is done, substitute all these values in the right hand side of this formula and you'll be able to get probability of A union B, which in this case is probability of selecting an apple or a good fruit. Okay. So now let's do the problem. The total number of fruits is apple, number of apples 20 plus number of oranges 10. So 20 plus 10, 30. That is N of S. Right? Number of apples is 20 and number of good apples is 20 minus 5. Rotten is 5, right? Rotten, out of which 5 apples is rotten. So 20 minus 5, 15 good apples are there. Similarly, number of oranges is 10. number of good oranges is, there are 3 rotten oranges. So it is 10 minus 3, 7 good oranges are there. So let's start. Let A be the event of taking an apple. What is n of A? N of A is number of apples. So that is 20, right? So probability of A is n of A divided by n of S. So n of A is, we just calculated 20, and n of S, that is number of total number of fruits is 30, right? N of S is 30, right? So that is 20 divided by 30. Now don't simplify it, keep it as it is. Let B be the event of taking a good fruit. Now we will have to first find n of B. How many good fruits are there? Good fruit means it can be good apple, it can be good orange, right? And we know, we just calculated here, number of good apples is 15, number of good oranges is 7. So it is 15 plus 7, that is equal to 22, right? So probability of B is n of B, that is 22, divided by n of S, that is 30, right? So it is 22 by 30. Next. Now let A intersection B denote a good apple. So what is A? A is selecting an apple, B is selecting a good fruit. So A and B, common to A and B is selecting a good apple. Okay. Now we just saw how many good apples are there? Good apples are there 15, and total number of fruits is 30. So n of A intersection B is 15, and probability of n of A intersection B is n of A intersection B divided by n of S, that is 15 by 30. So then we are using the law of addition theorem on probability. We get probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Probability of A selecting an apple is known. Probability of selecting good fruit is known. Probability of selecting a good apple is also known. So substitute all these values. Probability of A, we saw it is 20 by 30. Probability of B is 22 by 30. So 20 by 30, 22 by 30, and probability of A intersection B, we just calculated to be 15 by 30. Simplifying this, you will get 20 plus 22, 42, 42 minus 15 is 27 by 30, that is 9 by 10. So the probability of getting a good fruit, probability of getting a fruit which is either an apple or a good fruit is 9 by 10. Now let's extend the same problem like the previous case. Probability of selecting a fruit which is neither an apple nor a good fruit. How will you do? That is nothing but 1 minus 9 by 10. Okay. So I hope I made it clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.